Alright, welcome back. So here we are in Module 8. And you got hit with a lot in Module 7. And one of the things that we mentioned in Module 7 is that 7, 8, and 9 are all linked together. They're all machine learning. So let's start off with the fact that we're going to deal with unsupervised machine learning. We're going to focus on clustering. We're not going to have a whole ton of lecture on this. I want you to go spend time exploring and looking at the different things relative to clustering and unsupervised machine learning. Okay. So as we start going through this, we've got a data set and there's dimensionality associated with it. So let's say I wanted to take a deck of cards and identify clusters. And it could come out different ways. It could be the symbols, those clusters. There's so many different ways that these could be categorized or organized into groupings or clusters. Right. Generally, there's no correct clustering that'll take place. The models do the best they can with the settings that we've imparted on them. So we're going to have to pick a K, and whatever we choose K to be will impact the quality of the results. Clusters won't mislabel or label themselves. We have to do that after the clusters have been identified. Okay. So the model's going to go through and identify the clusters, but we've got to label them. If we're going to label them. So we start out with a set of k-means, which are points in D, or dimensional space. So we assign each point to the mean to which it is closest. So if no points assignment is changed, stop and keep the clusters. So it's like, wait a minute, what's he even trying to say? This is an iterative algorithm, and it's not the best way to word it, but this is the textbook definition of it. So if some points assignment is changed, recompute the means and return to step 2. So it's an iterative process going through it. Now, in chapter 5, and we're going through a number of pages when it comes to machine learning, when it comes to Vanderplas's textbook, he's got this notebook here for us. And I've got a link to it in the resources. I'm going to pull it up now. This is in-depth k-means clustering. So essentially when we look at it, we're going to do our imports and we're going to deal with k-means. So let's say here's the data we're looking at. And we can't distinguish one thing from another. They're all visualized the same color. But if we tell it to go identify clusters, so I want 4 centers, so it's going to be 4 clusters that I want it to go identify. I've got 300 different samples, and so let's do this. Okay, so it's set this up for us. We're going to go through it, and we tell it k-means. All right. N clusters. Number of clusters is 4. Run k-means on it, so we've got k-means. Fit the model. It's a k-means model. Predict what they are, and it goes through and it does it. So we end up with, so go ahead, scatter plot it for us, and by doing that, it gave each cluster a different color. So it took this, and we said, hey, break it up into 4 clusters. There you go. There's your clusters. Now, the k-means, what k actually means is the number of closest neighbors. All right, so we'll look at this a little bit further here as we go through it. We've got code where it goes through and looks at it. Here's how we've broken it up. and we see things are a little bit different. The colors applied are different. Not a big deal. Here it's gone through and we're doing it again, but it's a little bit different. It's saying, all right, here's a cluster, here's a cluster, and here's another one. It's like, wait a minute, it's a little bit off. So we've got different approaches that we can go through to try to come up with clusters. Here, we'll go through and, hey, instead of 4, let's try 6. 1, 2, 3, 4, 5, 6. Well, if we went 6, there you go. That's what you got to play with. If I looked at this as a human, I'd say, all right, there's a cluster and here's a cluster. The model didn't look at it that way. I said, all right, here we go. Here's one and here's the other. So it's not always right. It's not perfect. We may have to go through and modify things to ensure that it does identify clusters appropriately. Okay, so we've got a good notebook here that we can go through and play with. Here it's going through and doing clustering on digits. This will come in handy if we're going in and looking at things relative to, let's say, one of the assignments that you're dealing with. One of the things that we see is k-means for color compression. Now, let's say, wait a minute, what's going on? What are you even talking about here? So I'll just say, I'm going to leave this here, and you can go play with this, the code part of it, and look to see what's going on here. I'm going to jump back to where we were on the slide deck. So we go through and we've got expectations and we see what's what relative to how we're going about things step by step, and it may or may not be how we want it. And essentially it goes through and it says, all right, we have 4 different ones, and then we just start grouping from there. And things may get reassigned. So initially they said, all right, here's purple. And as we went through each step, no, purple's out here. That's not really purple, that was yellow. And it goes through and it's shifting as we go back and forth until we get the final clustering of it. It says, all right, here's where we end up. So there's the steps that it would go through and take. And there's a lot of back and forth. How do we pick what the perfect K is? And it's difficult. It really is. There is no one perfect K. It's all situational. So we got to go try it with different values for K. Here's an example of where we looked at unsupervised digit classification. They came up with a 92% accuracy on these images, and they're really pixelated. So the quality of the image is vital when we're talking about classification, or if we're going through and we're doing clustering. This is a classification doing unsupervised. So color compression. We're looking at the difference between green and red on color compression on 16 million different colors. Here we reduce the color space. Okay, 16 million possible colors, 16 possible colors. And by doing it, things look differently. See what things looked up here and what they look like now. So essentially the same kind of concept. Here's the original image. Let's look at it when we only have 16 colors available to us. Muted, pixelated. So the compression of the image is a big deal. And we may have software that'll go do this so that we're more efficient, but we've got to understand that being more efficient may impact our accuracy. Difference between the original image and 256. It doesn't look that bad. So how far you compress, are you going from original to 256 or original to 16, matters. Okay. Our accuracy or our ability to classify things beyond that, things get lost in the haze, if you will. There's a ton of literature available to us when it comes to clustering unsupervised learning. All right. If we go back and we pull up this and we look at it again, we've got the code where we go through and we're trying to reshape, rescale, and we look at those differences. Here's what we looked at, but here's now the coding associated with it. Okay. So go through, play with this. Identify other examples, great resources that help you, what works, what doesn't work. Share that in your reflections. Okay. So with that said, I told you that 8 and 9 are going to be considerably shorter than our Module 7 was. Okay. So keep in mind you've got an assignment coming up. Let's go pop over here and look. You've got assignment coming up from Module 5, Assignment 3, Statistics, Probability, Distributions. Gonna be due, coming up soon. Always be looking at the calendar, what's coming up. Got that link to Responsible Machine Learning there available, still available. I posted that in Module 7 as well. And you'll see that again in the final module, Module 11. All right. Section 5. It's chapters 37 to 47. So there's a lot available in there. They're not super long chapters, but there's a lot of content there when it comes to machine learning. So spend some time going through the Vanderplas text and the notebooks that are associated with it. You've already been provided the link to get to Jake Vanderplas's GitHub repo. A lot of stuff there available to you that can be very beneficial when it comes to stuff like what we've got down here due shortly. All right. Ask questions early and often. We'll see you in next module.